Hi, everyone. Thanks for doing this so that our schedule isn't completely messed up. We're just going to briefly go through section 6.6. A bunch of this is review. Of course, a little bit is stuff that you know and kind of taking it to the next level. But let's first start with some vocab and just remind ourselves of some vocab here. Earlier in the year, we talked about our different types of real numbers. We talked about rational numbers that can be numbers that can be written as a fraction. And then irrational numbers is basically everything else. A rational number, if we're talking about decimals, ones that aren't already as a fraction, we can have decimals that terminate or decimals that repeat. So for terminating decimals, I basically think about decimals that ends. Repeating decimals, I think about repeats, but they don't end. Some examples could just be 0.25. For repeating, it has to have some sort of pattern. It can be short, it can be long, right? And we do things like 0.3 repeating. We could have a number out in front in our whole number part. So we could have negative 21.3712. The entire thing doesn't have to repeat. Just the 1, 2 could repeat. And it would be 3, 7, 1, 2, 1, 2, 1, 2 forever and ever. For our irrational numbers, we can have patterns as long as those patterns don't repeat. So my favorite example of this is something like 0.01, 001, 0001, and so on. There's a distinct pattern. You could tell me what comes up next, but I can't make a stamp that says 1, 2, like in this example up here, and just stamp, stamp, stamp forever and forever. So that's kind of an example with a pattern. Irrational numbers that have no pattern are things like pi, any square root that we don't know, so the square root of 2, and it doesn't have to be a square root. It could also be a cube root. So say we know the cube root of 8. We don't know the cube root of 9. That would be also an irrational number. So as we look at some examples here, there are some that are very straightforward. So these couple in purple, I've highlighted very straightforward here. It's already a fraction for number 1 here. So it is definitely rational, but it is also real. Rational, if you remember, our shorthand was the Q, so you could write it like this, or I'm okay with just saying RR when I ask you a question like this. Number 3, again, it's a decimal that ends, so this is definitely rational. No matter what, if it's rational or irrational, they are all real numbers. Number 8, I don't care that there's a 2 on the bottom. The problem is that there's a root 2 on the top. This one is very clearly real irrational. And then 9, that was one of our main examples. A few of these in green, though, you've got to do a little bit of work sometimes. So number 4, I look at it, I'm tempted to say that number 4, well, I don't know the square root off the top of my head. But you've got to do your work with your square roots. What is this? This is 1 in the hundredths place. So this is 1/100th. Oh, wait, I know both of those square roots. And so my answer here is going to be 1/10. That means that this is real rational. If it was just 0.1 instead, so the square root of 1/10, well, that one I don't know. That would be real irrational. So you got to really make sure you do it out. There's no kind of hard and fast rule for a question like that. Number 5, that's a cube root. Oh, wait, I know the cube root of 8, so that one is rational. I don't know the cube root of 9, so that one is irrational. I highlighted number 10 for a very specific reason. In this past chapter, we've been doing things like 3x plus 6 all over 3, and we split it up. You are only allowed to do this when there's one thing on the bottom, or I guess if there's more than one thing on the bottom you can divide, but you can always have to divide by the entire bottom. So there is no splitting up of number 10. There's a pi involved, and so immediately I think this is probably real irrational. 11 and 12, just real quick, I've got to do these out to make sure I know what's going on. I've got 2 root 3. I've got another 2 root 3. Oh, 2 times 2 I know. Root 3 times root 3 is just 3. That means that that's going to be rational. For number 12, I add one more radical on there because now I'm cubing it. These two canceled, right? This was real, but now it's going to be left with a root 3 in there. And so this one is now irrational. So there's no real good rule. You can't really say exactly what it's going to be on some of them without doing a little bit of workout. But these are pretty nice questions, pretty quick, if you kind of are feeling good with your square roots. All right, now here's the new thing. So converting between decimals and fractions. 13 and 14, very quick. We've done this since junior high. What is a fraction? Really, it's just a division without a calculator. The top number goes in, your bottom number goes outside, and you just have to do your long division. I actually am going to do the long division because you're going to see soon we're going to actually do long division, but with more complicated stuff. So let's see, 11 doesn't go into 6, so that's 0, which of course it better be because 6/11 is less than 1. Let's see, 11 goes into 65 times, that's going to be 55. I'll subtract, I get 5, add another 0. 11 goes into 54 times, that's 44, I get 6, subtract. It goes in 5 times, that's going to be 55, subtract, add a 0, it's going to be 4 times. I think you can see that this is going to keep repeating. So our answer is 0.54 repeating. For question 14, again, very straightforward. If you remember reading your place values, that's exactly how you're going to write it as a fraction. Tenths, hundredths, thousandths, 10,000ths. So 1875 over 10,000, and now you just have to simplify. I need to figure out what goes into both of these. I don't know off the top of my head, but I do know that 5 goes into both, so I think I'll take this bit by bit. I know 5 goes into 1875 375 times. I know that 5 goes into 10,000 2,000 times. Okay, well, both of those still can be simplified by 5. So 375 is 75. 2,000 is going to be 400. And now, let's see, again, I can divide by 5. If you notice that you can divide by 25, you could also do that. I divide out a 25. I divide out a 25. And there is my fraction. Those ones we should have been able to do before today. However, our new thing is now we're going to be able to write any fraction whatsoever as a decimal. Sorry, any decimal whatsoever as a fraction, even if it's repeating. Of course, there's ones that we just know, right? 0.333 repeating. Well, we just know that that's 1/3. But I don't want ones that we know. I want any of them. We're going to do this in a little bit roundabout way. I am going to make up a statement, and I'm just going to call my number here n, which is 0.83, 83, 83, and so on. Now, I'm going to look at my number, and I'm going to look at how much is repeating. And I want to somehow get the same decimal place, 0.8383 repeating, but I'm going to multiply by some number, some magnitude of 10. And so here I'm going to multiply my n by 100. And what do I get? Oh, I should move these over a little. What do I get when I multiply my 100 times n? Well, on the left, I get 100n. On the right, I just move my decimal 2 places over. Now, this might seem kind of silly, but what I'm going to do is now I have two equations. I'm going to line them up above each other, and I'm going to subtract those two equations. On the left, 100n minus 1n is going to give me 99n. On the right, because I made sure that everything lined up, decimals gone, 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 gone forever and ever, and so I just have 83 left over on the right. Now, to get n alone, all I have to do is divide both sides by 99, and I've got to just make sure that nothing goes into 83 and into 99, because I do want to simplify. I don't think anything does, because 8 plus 3 is 11, and 3 doesn't go into 11, so I'm pretty sure that's my simplified answer. Number 16 is very similar, except only the 3 is repeating here. So this time I'm going to let n be 8.8333, and I kind of like writing a few of them out. I am not going to be able to line up my decimals perfectly here. I guess if you wanted to on the left-hand problem here, you could have multiplied by 10. I don't think that's great on a problem like that if I can make everything line up. I'm not going to be able to here. But I only have one number repeating, so I'm going to multiply the left by 10 and the right by 10. And then I'm going to line up underneath my n equals statement, and I'm going to subtract. Remember, to subtract your decimals, you need to line up your decimal places. Okay, let's see. The 3's are going to cancel. The 3's are going to cancel. The 3's are going to cancel. So at this point, I just have 8.3 minus 0.8. So I can just do this like my normal subtraction. This is 7. I've got to regroup. My decimal point stays lined up. 13 minus 8 is going to give me 5. I get 7.5 is equal to 9n. Oh, you know what? Maybe I should have multiplied by 100. I don't know if it would have actually helped me any. But here, I'm thinking to myself, I want to divide both sides by 9, but I can't mix decimals and fractions. So I think before I divide both sides by 9, I will multiply both sides by 10 in order to get rid of that decimal. All right, I will divide both sides by 90 now. I get 75 over 90. This time, I'm not done. This time, I'm going to go ahead and simplify because I know at least 5 goes into both of these. So 5 goes into 17 15 times, and 5 goes into 90 18 times. Oh, wait, I didn't get the biggest number. 3 goes into 15 5 times, into 18 6 times. These are awesome to check when you have a calculator because you can just type in 5 divided by 6 and make sure that that is the decimal that you get. Last question, find a rational and an irrational number between each given pair. We're just going to do these really quickly. For a rational number, one of the ways that you could do this that's really nice is to find the average. Add them up and divide by 2. So for rational, I will add 7/8 and 8/9 up, and then I will divide by 2. And this is a little bit of work. I think I maybe could convert both of them into decimals, but honestly, it's probably the same amount of work. I'm going to make these both out of 72, and that is going to be, let's see, I did 8 times 9, so 7 times 9 is going to give me 63. I did 9 times 8, so 8 and 8. And I don't want to forget, I'm dividing that whole thing by 2. That's going to give me 127 over 72. Dividing by 2 over 1 is the same as multiplying by 1/2. And so the average is 127 over 144. And that is in between those two numbers because the average is always going to be in between those two numbers. Ooh, to find an irrational number, well, that's not quite as easy. I could maybe use what I just did in order to find irrational. I could say, what were my two numbers? They were 63 over 72, and they were 64 over 72. Is there some sort of irrational number I know in between them? Sure. I guess I could do 63.01001001, but I don't love mixing my fractions and decimals. So I don't actually really like that answer. That's not a very good one. I think what I might have to do instead is I might have to go and figure out what these are as decimals and then do something like what I was just talking about. Because if I mix those decimals together, then it's a little bit better. There's a couple different ways you can do questions like this, and there's not really one answer. One thing that you can do that I think is what I'll do right here is I will estimate this answer on my calculator. So when I estimate this answer, I'm going to get 0.8819, and then I get 4 repeating. So let me just take that and let me just change it so it's irrational. How about 0.8819 440, 440, 4440, and so on. Getting from here to here, obviously I did need to use a calculator. We're going to have ones that are doable or that I will give you some freebies. Let's talk about number 18, and then you'll have some of these to practice. For number 18, I definitely want to write these two numbers out a little bit longer than they're written. So I'm going to write 0.4444, maybe a couple more, and then I'll have my repeating. I'm going to give myself some space. I have 0.454545 repeating. And I really tried my best to line up my place values because that's how I'm going to make sure that I have a number in between. So let's see, for my rational number in between, I have to be at least as great as this one, but I want to be less than this one. So I have to have 0. Oh, wait, they both start with 4, so I have to have a 4. Oh, shoot, there's nothing in between 4 and 5. I can't go below 4. I can't go above 5. I can't have it be actually 5. So I think I'll just keep that as a 4. Now I have my hundredths spot. I am, as long as I'm greater than 4 here, I'm going to be greater than the top number, and I am already less than the bottom number. So my next digit is a 4. I don't know, let's pick a 5, and my decimal is going to end, which means that it's rational. Oh, that's even better, because now for irrational, I can just take my answer and make it irrational. I know that 0.445 is in between my two numbers, so who cares what I add on now? So why don't I add on 3, 5, and then 3, 3, 5, and then 3, 3, 3, 5, some sort of pattern that is not a repeating pattern. Okay, and that's it. That's it for this section. So hopefully that helps. Try the homework, and then we'll go over questions when I see you next. All right, thanks everyone.